Alright, let's move along to the next question. Alright, so what is the integral of tan x to the power of 6? Okay. So to calculate this integral, let me write it down first. We're going to use a technique called substitution. So we're going to take our variable u and substitute it into our integral here to make it simpler to solve. Okay. So the integral of tan x to the power of 6. Okay. So let's say let u equal tan x. Okay. So if u equals tan x, then du of dx will equal to secant squared x. Okay, and that means that du equals dx secant squared x. I should write dx. So dx equals du over secant squared x. Okay. So then we're going to sub these two variables, or these two equations, into our integral. So sub 1 and 2 into integral. Okay. Cool. So now we got this integral in terms of du. Now we get u to the power of 6 divided by, let me just write it this way, u to the power of 6 divided by secant squared x of du. Okay. Alright, sure. So we know that based on our trigonometric identity, we have secant squared x equals 1 plus tan squared x. Okay. So we're going to sub that into our equation here. So sub 3 into integral. And now we get u up to power 6, 1 plus tan squared du. But we also know that u is equal to 10, so we can simply write u to the power of 6, 1 plus u squared du. Alright, cool. Now we're going to need to integrate this. It's not simpler to integrate, but we'll make it simpler, okay? So we're going to long divide, we're going to do some long division of u to the power of 6 divided by 1 plus u squared, okay? So if we're going to do long division here, I'm just going to do this. Alright, so our long division will look like, let me just do it in a different color too. So e to the 6 divided by e squared plus 1, okay? So we're going to try to get rid of this leading term by multiplying u squared plus 1 by a constant or a variable to a power or something, okay? So to get rid of u to the power of 6, we're going to times u squared plus 1 by u to the power of 4, and we get u to the power of 6 plus u to the power of 4. If we subtract that, we get negative u to the power of 4. We want to get rid of this leading term, so we're going to need to multiply this by negative u squared, and we get negative u to the power of 4 minus u squared. And if we subtract that, we get u squared. And we want to get rid of this u squared leading term, so we'll multiply this by 1, and we get u squared plus 1. If we subtract it, that equals to negative 1. So now we have a remainder of negative 1. So then the division of u to the power of 6 by u squared plus 1 is this. U to the power of 4 minus u squared plus 1 minus remainder of 1 over u squared plus 1. Okay, so we're going to take this long division and sub it back in. Okay, so this is 4. So sub 4 into integral. Okay, and that in this way we get the integral of u to the power of 4 minus u squared plus 1 minus 1 u squared plus 1 du. Okay, And now we're just going to integrate each of these. So we know that the integral of 1 over u squared plus 1, or 1 over x squared plus 1, is arctan, or tan inverse of u, okay? And we're going to be encountering a question that will prove that for us, but now we're just going to know for a fact that the integral of 1 over u squared plus 1 is arctan, okay? So it's going to be tan inverse of 1 of u. The other ones here are going to be 1 over 5 u to the power of 5 minus 1 over 3 u to the power of 3 plus u minus tan inverse u, okay? Cool. So this is now the indefinite integral. We need to add a constant because we have to be aware that it might be a constant. And we're going to sub back u in, okay? So sub u back in. And once we sub u back in, we get 1 over 5 tan x to the power of 5 minus 1 over 3 tan x to the power of 3 plus tan x minus tan inverse x, tan inverse of tan x plus c. Okay, so now we have found our integral after using substitution, okay? So let me just bring you guys to this question again using the junior tutor solution. So we use a technique of substitution to simplify our integral in a way that we can solve it. Okay, so we chose u to equal to tan x. We solved for the derivative of u in terms of x, and that was to be secant squared x, and then we isolated for dx. Once we got dx and u, we sub that into our integral to get this resultant integral. Now we know that based on the trigonometric identity, that secant squared x is equal to 1 plus tan squared x. Okay, so we sub that into here, and we know that u is equal to tan x, so we subbed u into our equation to get our integral all in terms of variable u. And by doing so, we're now able to integrate in terms of u. So during our integration, we use long division to write this out in its, I guess, its quotient form, or its divisor form. I don't really know what the word for it is, but we found this form here, which is easily integratable because we can use the sum rule for integrals, and we use the power rule to calculate these three integrals. And we know for a fact that arctan, or tan inverse, is the integral of 1 over u squared plus 1. And by doing so, we have found our integral. We added a constant in, and we subbed back u in, and we've now found our integral in the end, which is tan to the power of 5 divided by 5 minus tan to the power of 3 divided by 3 plus tan x minus tan inverse of tan x plus constant c. Okay, so this solution is correct. Cool. All right, moving on along to question